Hi everyone, welcome to the today's session. Before going to start the session, I have some questions for you. Well, why does a hot cup of coffee cool down over the time? And how we will going to boil the water? Yes, that is heat transferred from the stove to the kettle and then to the water, causing it to boil, right? How this heat energy transferred? Yes, right. All these are the fundamental examples of thermodynamics. Today we will going to study these thermodynamic topics. Yes, let's begin the session. Myself Sumalata S, Assistant Professor from the Department of Chemistry, SKNG GFG College, Gangavati. In this session, we will going to concentrate on the review of consequences of the first law of thermodynamics, spontaneous processes, statement of second law of thermodynamics. Right? Let's begin. Thermodynamics. What does it mean by this thermodynamics? Thermodynamics is the study of how heat and energy are related to other forms of energy and how they affect the properties of the matter. Right? It focuses on the macroscopic behavior of the systems, like how heat moves through an engine rather than the behavior of individual molecules. Right? Initially we discussed about the boiling of the water, right? How heat energy transferred from stove to the kettle, then to the water. This concept is understood by this thermodynamics. Okay. Next, coming to the first law of thermodynamics. What it states? The first law of thermodynamics, also known as the law of conservation of energy. It states that energy cannot be created or destroyed, but it can be transformed from one form to the another. Right? Here what happens? Energy can be transformed from one system to the another system without going any destruction or any creation. Okay. So this is also known as the law of conservation. Okay. Next, coming to the consequences of the first law of thermodynamics. Means, what are these implications? The first law of thermodynamics. The first one is the conservation of energy. Means, the most fundamental consequence is that energy is always conserved. Means, it can change from one form to the another, but cannot be created or destructed. So, total amount of energy in the universe remains constant. This is termed as a conservation of energy. Understood? Next, second consequence is the internal energy changes. A thermodynamic system in an equilibrium state possesses a state variable known as internal energy. Means, here what happens between the two systems? Okay, this is the one system, this is the another system. Here what happens? The change in the internal energy is equal to the heat transfer into the system and work done by the system. Okay, what is the change in the internal energy is equal to the difference of heat transfer into the system and work done by the system. When a system exchanges energy with its surroundings, it changes accordingly. Okay, here change in the internal energy is given by the difference between the heat transferred and work done. Okay, this is the another consequence of the first law of thermodynamics. Okay, next, third one is the limitations on the perpetual motion machine. What is this perpetual motion machines? Means here the first law implies that it's impossible to create a perpetual motion machine of the first kind, means which would produce work without consuming energy. Okay, perpetual motion machine means it is going to produce the work without consuming the energy. That is our concept. Okay, that perpetual motion machine. Okay, since energy is conserved, any machine that outputs work must also consume energy in some form. Okay, any machine, it can have to produce the work, means it also consumes energy, either some form. Okay, that is the concept of the first law of thermodynamics. Okay, but here this perpetual motion machine says that it will produce the work without consuming the energy. Okay, so this is the limitation for the perpetual motion machine. Okay, next, relationship between the heat and work. What is the relationship? From the first law of thermodynamics, we can establish a relationship between the heat transfer and work done. Okay, how? If a system does a work, means it must lose the energy, that is either in the form of a heat or in the internal energy change, right? If a system have to do the work, means it must lose a energy either as a heat or a change in the internal energy. Then from the first law of thermodynamics, it is given by the change in the internal energy, del U equals to Q. Q is the amount of heat transferred minus work done. Okay, this is the relationship between the heat, work done and change in the internal energy. Okay, next, S law. Okay, another consequence of the first law of thermodynamics is the S law. The first law forms basis for a S law in the chemistry. This is also known as S law of constant heat summation. Okay, what it says? At a constant temperature, heat energy changes. At a constant temperature, heat energy changes accompanying a chemical reaction will remains constant irrespective of the way of reactants react to form the products. Okay, it means the enthalpy change for a reaction is the same whether it occur in one step or multiple steps. Okay, see here, in the first step what happens? A will going to react and give the product B. Okay, there is no intermediates, so change in the enthalpy for this reaction is the delta H1. Okay, this is the one step reaction. Okay, in next reaction what happens? The same A, initially it going to changes to C and then to the B. Okay, here the change in the enthalpy for the conversion of A to C is delta H2 and change in the conversion for the change of C to B is delta H3. Okay, so overall change in the enthalpy is summation of this delta H2 and delta H3. Okay, next if we go through the other two intermediates means A is going to change to the D, then D is changes to E, then E is changes to the B. Okay, here conversion enthalpy change for the conversion of A to D is delta H4, and enthalpy change for the conversion of D to E is delta H5, and enthalpy change for the conversion of E to B is delta H6. Okay, so overall enthalpy change required to convert this A to B is summation of all these enthalpy changes, right? That is delta H4 plus delta H5 plus delta H6. Understood? This is means the change in the enthalpy is almost same whether it is reactions goes through either one step or in the multiple steps. Okay, so this is about the S's law. Okay, these are all about the consequences of the first law of thermodynamics. Okay, next coming to the spontaneous process. What is this spontaneous process? A spontaneous process is one that occurs naturally under a specific set of conditions without any external energy input. Okay, means spontaneous process is one that occurs naturally without any external energy input. That is known as the spontaneous process. It characterized by negative change in the Gibbs free energy, means delta G must be less than 0 to for the spontaneous process to takes place. Okay, this spontaneous process are generally irreversible. Okay, meaning they don't spontaneously reverse their direction. Means if A will going to convert into the B, means this if this is the spontaneous process means in reverse direction it is not going to proceed. Okay, that is the spontaneous process. Spontaneous process are always irreversible. For example, the melting of the ice. Okay, the melting of the ice is the spontaneous process. Why? That not require any external energy, right? And reverse of that reaction means water gets converted into ice is that requires the energy, right? That is not the spontaneous process. Okay, melting of ice is the spontaneous process. Freezing of water is not the spontaneous process. So spontaneous process are generally irreversible in nature. For a process that occurs at constant temperature and pressure, the spontaneity can be determined using the Gibbs free energy, that is given by the delta G equals to delta H minus T delta S, where delta H is the change in the enthalpy for a reaction and T is the absolute temperature. Delta S is the change in the entropy. Okay, entropy, it measures the disorder or randomness of a system. We will go into discuss it later. Okay, and also this spontaneous process can be fast or slow. Okay, whether it may be fast reactions or it may be slow reactions. For example, melting of a ice, it is faster reactions. Okay, and rusting of the iron, okay, that is the slow reaction, right? So spontaneous process may be whether it is a fast or slow reactions. Okay, next. Okay, for the spontaneous reaction to takes place, the change in the Gibbs free energy must be negative. Okay, if delta G is positive means the process is non-spontaneous. Okay, if delta G is 0 means the process is at the equilibrium. Okay, if delta G is less than 0 means it is a spontaneous. If delta G is more than 0 means it is non-spontaneous. If delta G equals to 0 means the system is at the equilibrium. Okay, next, second law of thermodynamics. What is this second law of thermodynamics states? The second law of thermodynamics essentially states that the total entropy of an isolated system can only increase or remain the same. It will never going to decrease. Okay, isolated system, its entropy is always going to increase or otherwise it will remains constant, but it never going to decrease. Okay, this is the second law of thermodynamics. The second law says that in any natural process the total entropy of the universe is always increasing. Okay, this is concerned with the direction of the natural process, means it asserts that a natural process runs only in one sense, means this is not in the reversible direction, right? Well, the heat is always transferred from hot body to the cold body, right? This is a natural process, but heat cannot be transferred from cold to the hot body, right? So in nature the always natural process runs in only one direction, means total entropy of the universe is either increases or it remains at same. Okay, it will not going to decrease. This is about the second law of thermodynamics. Okay, yes, from this session we came to understand that consequences of the first law of thermodynamics, spontaneous processes, and second law of thermodynamics. Thank you for watching.